So our job in this example is a bit more involved than the previous example for a couple of reasons. First of all, we have to account for the direction of the power that's associated with each element. Well, we know the direction of the power associated with the resistors. It's going to be absorbed. But we're not sure about the 10 volts versus the 5 volts. You know, a sort of conventional wisdom would say the 10 volts is more powerful, so it'll be pushing current back into the 5 volts. We'll see. Sometimes conventional wisdom is correct and sometimes it isn't. But there's another reason why this example is harder, and that is that we really don't get anything at the start. We have to calculate everything from scratch. So we're going to need to have the voltage and the current associated with each of the 5 elements in this circuit. Now, we already have the voltage associated with the 2 voltage sources, but we don't have the currents. So we're going to need to do some labeling. We're going to need to do some calculating before we can even get to the power. Now, when I look at this circuit, if the job were recast as, please calculate the currents going through each of those resistors, or please calculate the voltages across each of those resistors, I look at it and I'd see that this top left-hand corner here is a known voltage. That's 10 volts, especially if we take the bottom here to be our reference node. And then this voltage is 5 volts. That means that there are 4 nodes in this circuit, and 3 of them are already known. The only unknown node is right here. And so if I could calculate that node, voltage, then I think everything else would fall into place. So what I'm going to do is I'm going to sort of treat this as a very simple nodal analysis problem, where I've simply got V1 is the only node that I need to calculate the voltage for. I'm going to go ahead and calculate the current that is leaving V1 in this direction, the current that's leaving V1 in this direction, and the current that's leaving V1 in this direction. I'll go ahead and write the one nodal analysis equation over here. So this will be KCL at V1. So I'm going to have, the first current is going to be going out to the left. So this is V1 minus 10 divided by 2, plus the current going out to the right, V1 minus 5 divided by 4, plus the current going downward, V1 minus 0 divided by 5 is equal to 0. One equation, one unknown. I can probably most easily solve this by multiplying both sides of the equation through by a common denominator. Here, it looks like 20 is probably the common denominator. So I'm going to multiply both sides by 20, and I end up with 10 times V1 minus 10 plus 20 divided by 4 will be 5 times V1 minus 5 plus 20 divided by 5 is 4 times V1 minus 0 is equal to 0. And then I can group like terms. So I'm going to have 10 V1 plus 5 V1 plus 4 V1 minus 100 minus 25 is equal to 0. And then V1 is going to end up being, move the negative 125 over to the other side. Factor of V1 out, you get 19 V1. So I have 125 divided by 19, which it turns out is 6.579. 6.579 volts. Okay, so we've now found the first step toward our answer. I'm going to go ahead and label a few more things in this circuit. I'll go ahead and call this I sub 2 ohms. That's about the most descriptive name that I can come up with there. I sub 5 ohms, and this will be I sub 4 ohms. I'm going to go ahead and call this V sub 4 ohms, plus to minus, V sub 2 ohms, and I'm going to put the plus on this side so that the current is flowing into that terminal, and this can be V sub 5 ohms, plus to minus. Okay, so once I've found once I found V1, now I can list the other 3 voltages in terms of V1. So V sub 2 ohms, well, that's going to be the voltage on the right, which is V1, minus the voltage on the left, which is 10. So V1 minus 10, 6.579 minus 10, which it turns out is negative 3.421 volts. V sub 5 ohms is going to be V1 minus 0, which is just 6.579 volts. And then V sub 4 ohms, well, that's going to be V1 minus 5, which is 1.579 volts. And then I can calculate the currents associated with each of these. So I sub 2 ohms, well, that's going to be V sub 2 ohms divided by 2 ohms. And that's going to be negative 1.710 amps. I sub 5 ohms, that's V sub 5 ohms divided by 5 ohms, which is positive 1.316 amps. And then I sub 4 ohms, this is V sub 4 ohms divided by 4 ohms, which is 0.3948 amps. Probably carried too many significant figures there, but I'll trim them at the end. So we now know, now we know the voltage and the current associated with every element. Because by the way, this I sub 2 ohms, that's the same I sub 2 ohms that is going to be flowing down into the positive terminal of the 10 volt source. And I sub 4 ohms is also the current associated with the 5 volt source. So we have 5 elements, we know the 5 voltages, and we know the 5 currents, so now we can just multiply them to get the 5 powers. So P sub 2 ohms is going to be negative 3.421 volts multiplied by negative 1.710 amps, which it turns out is 5.85 watts. And that will be absorbed. We know that it's absorbed because the current is pointing directly into the positive terminal. So this current I2 is flowing into the positive terminal right here. And since this number turned out to be positive, we know that the resistor is absorbing power, but we knew that the resistor was going to absorb power. It's just nice to have it verified by our math. P of the 5 ohm resistor, well, that's going to be 6.579 volts multiplied by 1.316 amps, which is 8.66 watts absorbed. P of the 4 ohm resistor is 1.579 volts, whoops, I put volts twice, multiplied by 0.3948 amps, which it turns out is 0.62 watts absorbed. Okay, now we can calculate the power associated with the 10 volt source. Well, let me scroll back up here and just verify I sub 2 ohms, the arrow is pointing into the positive terminal, so therefore all I have to do is just say whatever I sub 2 ohms is, I multiply it by 10 volts. So I sub 2 ohms, looking over here, that's negative 1.71 amps. So this is going to be negative 1.71 amps multiplied by positive 10 volts is going to give me minus 17.10 watts absorbed, which is the same thing as positive 17.10 watts supplied. So far I've seen that my 3 resistors are correctly absorbing power, and this 10 volt source is now supplying power, and the only thing that really remains unknown is the 5 volt source. So the power associated with the 5 volt source. Again, I'm going to double check. I sub 4 ohms is pointing into the positive terminal. So whatever I get for I sub 4 ohms, which it turns out is 0.3948, so 0.3948 amps multiplied by 5 volts, and that's going to give me 1.97 watts absorbed. And because that number is positive, I know that the 5 volt source actually is absorbing power. So the 10 volt source is the only one that is supplying power, and the other 4 elements in the circuit are all absorbing various amounts of power that's being supplied by that 10 volt source.